everyone, good day. I am Azuwan Maoinser, researcher of COR, specialized in mechanical sand control, will present to you SRT-350. Sand retention test is an equipment used to evaluate the performance of sand screen in laboratory scale. Two tests can be conducted using sand retention test. The tests are slurry test to simulate the gradual formation failure downhole and pre-pack test to simulate the borehole collapse happen in downhole. In sand retention test, depending on type of test to be conducted, various factors can be studied such as various type of stream, various sand size considering particle size distribution and uniformity coefficient, flow rates and fluid time. Responses evaluated are amount of sand produced, differential pressure and flow rate. In sand retention test 350 or SRT-350, the equipment has the capability to run the experiment in high pressure, which is 5000 psi equivalent to 350 bar, and temperature up to 120 degrees Celsius. This is the only SRT equipment that run with high pressure, high temperature condition. As mentioned in feature at Humvee 2018, to address the issue of faster settling rate of larger particles, this equipment is developed to encounter this issue by minimizing the distance between from the particle injection into the brine stream to contact with the screen. In SRT-350, the main components of the equipment are reservoir fluid tank, two pumps, injection pump and syringe pump, sand retention test cell, sand injection cylinder which can consist of 300 ml slurry, back pressure regulator system, effluent collection system, graphical user interface or GUI, and last but not least, the temperature measurement system. Before we analyze the sand screen performance using sand retention test, the particle size distribution of the sand formation need to be evaluated using dry sieve analysis. In UTP, we can conduct the dry sieve analysis using various sieve size ranging from 63 micron up to 425 micron. Further, we can also develop the synthetic sand that have similar characteristic with formation sand using the dry sieve technique. This will assist us to encounter the issue of limited formation sample to be tested in SRT. Since the dry sieve capability limited to the minimum of 63 micron, we extend the in-depth analysis of sand PSD using LPSA. The LPSA can measure the size distribution of sand ranging from 10 nanometer to 350 micron. Thus, we are able to analyze the sand size of lower than 63 micron. Comprehensive method towards PSD analysis and synthetic sand development could be done using both dry sieve and LPSA method. Two tests can be conducted using SRT-350. The first test is constant drawdown test. The procedure for these tests are: pump 1 will supply the fluid from the reservoir into sand retention test cell at constant pressure. To ensure the pressure inside the SRT cell maintained at constant pressure, back pressure regulator system is introduced at the outlet just before the effluent collection system. Pump 2 will supply fluid into the slurry injection cell that will inject slurry into the fluid stream. Pressure transducer are connected from each point, such as injection cylinder and sand retention cell to the graphical user interface GUI, where data are logged to monitor the pressure in real time. The effluent collection system consists of effluent collector and weight balance, will measure the collected effluent per time in minutes or hour, which will give the flow rate measurement in constant drawdown test. For constant flow rate test, similar component as constant drawdown test will be used in this test. However, the measurement system is different than constant drawdown test. In constant flow rate test, constant fluid flow rate will be supplied by pump 1 and sand will be injected from the slurry injection cylinder at constant flow rate. Pressure are measured before and after the screen to indicate the differential pressure occurred during the constant flow rate test. Customized differential pressure system is used for the differential pressure measurement. Effluent will be collected at the effluent collector system. The fluid is dried in the oven and the amount of sand it produced is measured. The capability of SRT-350 made us confident to have various collaboration with industries and other institutions. We are looking forward for any collaboration initiative toward the betterment of mechanical sand screen performance evaluation and selection. Thank you.